So we talked about systems of linear equations in two variables. Now we're going to look at multivariable linear systems. So you can see in example number 1, we have 3 different variables that we're working with here. Okay, now the nice thing about this particular system is we already know what one of the variables is, so we can just take that and plug it into the previous equation because that's going to help us solve for y. And so we just plug in 5 for z, and so 2y is equal to 2 because 7 minus 5 is 2. So then y is going to be 1, and then we can take the 5 and the 1 and plug those into the original, or not the original, but the first equation. So 3x plus y, which we know is 1, minus z, which we know is 5, equals 2. So 3x minus 4 equals 2, and then we add the 4 to both sides. So 3x equals 6. Divide both sides by 3, so x equals 2. So we have, and then we put this in alphabetical order. So 2, 1, 5 is the point for our answer. Or it's not really an ordered pair because it's on 3 dimensions. All right, so we have these row operations that we can use. We can interchange 2 equations, meaning we can switch them. We can multiply an equation by a non-zero constant, and we use that when we're doing elimination. And we can add a multiple of one equation to another equation. So there are different things that we can do here with our systems of equations. And so for this example 2, we don't have any variables by themselves yet. So we're going to take a look, and there are multiple ways you can approach these problems. So what I'm going to do is I am going to, let's see, I will first, I'll take those first 2 and rewrite them down here. Because I noticed that I have a negative z in the first one and a positive z in the second one. So I can just go ahead and add those 2 equations. And that will cancel out my z's. So then I'm down to 2 variables for this equation. And that should not be a 12 because this should have been a 4. All right, so that should have been a 4, so that's a 10. Okay, helps to follow your own notes. Then the next thing that I can do is I'll take my first and my last equations, and again I can get rid of my z if I multiply that, I'm sorry, the second equation. So if I multiply this second equation by 2, I end up with 2x minus 6y plus 2z equals 8. And then I can take that third equation, the 3x minus 16y minus 2z. So my z's are going to cancel, minus 10 or negative 10. So then when I add, I get 5x minus 22y equals negative 2. And so now I have a system of equations here. If I look at the 2 that I just found. So I can take my 5x minus 22y equals negative 2. And then if I take the first equation that I found and I multiply that by 11, that'll get my y's to cancel. And so I get, I'm sorry, negative 11, because I want that to be 1 positive, 1 negative for the y's. So I get negative 33x plus 22y, so that's where my y's are going to cancel, equals negative 110. And so when I simplify that, or when I add those together, I get negative 28x, my y's cancel, equals negative 112. When I divide both sides by negative 28, I get 4. Okay, and then I can take that 4 and I can plug it into one of those equations that I just found. So I'm going to plug it into this one. So I have, oh, that was supposed to be an x right here. I don't know why I put a y there. Okay, so I have 3 times 4, because remember we just found x to be 4, minus 2y equals 10. So 12 minus 2y equals 10. So negative 2y equals negative 2. So y is 1. And then you can take one of your original equations and plug in your x and your y to get the z. So I'm just going to take the first equation. So 2 times 4, and again, this is the original equation, the very first one, plus 1 minus z equals 6. So 8 plus 1 minus z equals 6. So 9 minus z equals 6. So z has to be 3. So our answer is 4, 1, 3. Again, we put that in alphabetical order. All right, let's take a look at example number 3. Again, we're solving the system of linear equations. And so what I'm going to do first is I am going to, I'm just going to add the first 2 together. So I'm going to take those and I'm going to add them together. So x minus x is 0. Negative y plus 3y is 2y. 2z minus z is z. And 5 minus 2 is 3. Okay, and then what I'm going to do is I'm going to multiply, let's see, I will multiply the first equation, the second equation by 2, and then I can work with the second equation and the third equation. Because remember, the first thing that we did was equations 1 and 2, was this one. So now we're going to be working with equations 2 and 3. Okay, so we've got negative 2x plus 6y, remember that I'm distributing that 2, minus 2z equals negative 4. And then we just bring our third equation over. Okay, and so then we can add those. And when we do that, our x's cancel. We get 2y plus z equals 3. And look at that, we get the exact same equation. And so then we have infinitely many solutions. Well, how can we write what those solutions would be? So here is where we are going to let z equal a. Sorry about that. We're going to let z equal a. So that means that 2y plus a equals 3. And that just came from these two equations that we had here. And so we can solve for y. So 2y equals 3 minus a. So y equals 3 halves minus 1 half a. Okay, so we have our z and we have our y. And now we're going to plug into the original, the first equation, these expressions that we have for z and for y. So we have x minus, and then it's 3 halves minus 1 half a, plus z, which was, no, not plus z, plus 2z, which is 2a, and that equals 5. Again, we just plugged in y and z into that first equation in the original problem. So x minus 3 halves plus 1 half a plus 2a equals 5. So if we add that 3 halves over and we combine these, we end up with 5 halves a there for that. And if we add that 3 halves over, we end up with 13 halves, because remember 5 halves is 10 halves, and then you add 3 to that. And so x is going to be 13 halves minus 5 halves A. So then whatever value for A you have, you know what all of those, oh, that's not a 15. You know what all of those values are to be for X, Y, and Z. All right, so there's your X. And then remember Y was 3 halves minus 1 half A. And then Z was just A. So this is how you can write the rule, basically, for all of those solutions for the system of equations.